Now we're going to study the electrostatics. First, we're introducing the charge, the term charge. Actually, the charge is like a physical quantity like mass, as well as if we apply a force on a mass, we get an acceleration. That is, force equals to mass into mass times the acceleration. So whatever may be the acceleration, we get the mass times of that acceleration is the force. In that case, in the case of charge, when we introduce the charge is that physical quantity which is responsible for force in case of magnetic and electric field. Electric field and magnetic field. That is called charge. In an atom, there are equal number of positive charges and negative charges. The positive charges comes from the proton and the negative charges come from the electron. So, as a whole, the total charge is 0 because the electron and proton has the equal amount of charge and both are equal and negative, equal and opposite. So, the total charge of an atom is 0. That is, the atom is neutral, electrically neutral. Now, we know the quantization of charge. Quantization. So, what is the quantization? As you know, when we going up or down through the stairs in our home, the stairs are counted 1, 2, 3, 4, 5, etc. etc. Anytime we haven't count as the number of the stairs as 1.5, 3.7, not so. Where we have to count 1, 2, 3, that means total integer full number. Just like that, in the case of the charges, in any charged object, the charge should be expressed in electronic unit. The charge of electron. The charge is expressed as 1 of electron, 2 of electron, 3 of electron, in such way. That is called the quantization of charge. So, we never express the charge as the fractional multiple of the charge of electron. There are some exceptions in the modern science of the quantization of charges. Basically, in the case of the particle physics, after introducing the quarks, the charge may be fractional amount, that is 2/3 of electronic charge, 1/3 of electronic charge. Such kind of charges can be found after introducing the quark concept in the particle physics. Now we are discussing about the conservation of charge. The total charge, that is the algebraic sum of the positive and negative charges in an isolated system, remains constant for all times. This is known as the conservation of charge. So, by the isolated system, we means that there is no charge is allowed to cross the boundary of the system. No charge can go out or come in of the system. This is the law of conservation of charge. If we give an example of the pair production, that is gamma to positron and electron pair, that is this is 0 and this +1 and -1 combined to 0, whereas this is 0 and 0 combined to is 0. In any of the nuclear reactions, we can find such type of charge conservations. Now, we introduce the Coulomb's law. So, what is the Coulomb's law? The Coulomb's law describes about the electrical force between the two charges. According to the Coulomb's law, that force will be proportional to the product of the two charges and inversely proportional to the distance, the square of the distance between the two charges. The two charges must be point in dimension. Here actually the distance is the relative distance between them. If we take a coordinate system, this is R1 and this is R2, then the relative vector is R12 or R21, whatever we can take according to our requirement. Then we get the Coulomb's law by combining these two, Q1, Q2 by R square, and when we take a constant 1 by 4 pi epsilon 0, we get the total formula F equals to Q1, Q2 by 4 pi epsilon 0 R square in SI units. That is, the force will be found in Newton. So here the 1 by 4 pi epsilon 0 is the proportional constant, and epsilon 0 is called the permittivity of the free space. This is the Coulomb's law. So the Coulomb's law have some limitations. The Coulomb's law cannot be applied other than the point charges. The Coulomb's law breaks down for the very low distances. The distances like the nuclear diameter 10 to the power minus 15 meter, of the order of 10 to the power minus 15 meter, the Coulomb's law fails. This is the limitation of the Coulomb's law. Now we read about the principle of superposition. The total force on a charge due to the number of other charges is given by the vector sum of the Coulomb forces exerted on the charge due to each of the other charges acting separately. So if we take a simple charge Q1 and there are several charges surrounding the Q1, so this is Q2 independently acting on it, then we get a force F21. This Q3 acting on Q1, independently we get F31. So when all the charges act on the charge Q1, the total force of action is F equals to the vector sum, that is F21 plus F31 plus up to whatever may be the number of charges.